Hello learners, welcome to my channel. My name is Teacher Alice. I will be your chemistry teacher, and in this lesson we are going to look at a Form 1 topic. The title of the topic is Water and Hydrogen. So in our lesson we are going to look at the first part 1, and that is hydrogen. So what can we say about hydrogen? We can say that hydrogen is the simplest and lightest element. So of all the elements, hydrogen is the simplest and the lightest. Hydrogen does not occur freely in air, but rather it occurs in compounds. So we are going to look at how can we prepare hydrogen gas in the laboratory. So in school, we can prepare hydrogen gas, and this is how we are going to prepare hydrogen gas. So from a previous topic, that was acid, bases, and indicators, we saw that to prepare hydrogen gas, we can react acids and metals. So we saw that when we react an acid and a metal, we produce hydrogen gas and a salt. So in this topic, we are going to look at those acids and those metals that are used in the preparation of hydrogen gas. So not all acids and not all metals are used in the preparation of hydrogen gas. So hydrogen gas is prepared by the reaction between dilute acids and some metals. So some of the examples of the dilute acids that we use is 1, dilute hydrochloric acid and dilute sulfuric acid. So those are the most commonly used acids, and remember, they must be dilute. So in our experiment today, we are going to look at the laboratory preparation of hydrogen gas. So we have an experiment here. So this is our experiment. You can see we have our conical flask here. It contains zinc granules. So we put our zinc granules in our conical flask, and in our dropping funnel, we place our dilute hydrochloric acid. You can see that. So now when we are going to open this tap here, we are going to release our dilute hydrochloric acid slowly, and it is going to react with the zinc granules. So there will be production of a gas. So we are going to produce some bubbles here. So some bubbles will be produced here. That is, the bubbles will indicate the production of a gas. The gas is colorless. It will move through this delivery tube all the way to our test tube here. So it can be a test tube, it can be a gas jar. So we are going to collect our gas now through a method known as overwater method. That is because hydrogen gas is less soluble in water, so it is not going to dissolve in water, and we are going to collect it up there. We can also collect hydrogen gas through this other method here, known as the downward displacement of air. It is also known as upward delivery method. So we can, if we want to collect our dry hydrogen gas, we are going to pass it through a conical flask containing concentrated sulfuric acid. So in this conical flask here, we have concentrated sulfuric acid. It is going to dry our hydrogen gas, and now we can collect it on that gas jar there. Now we can use our dry hydrogen gas as indicated there. So you can see that zinc granules will react with dilute hydrochloric acid to form a salt. That the salt will be zinc chloride, and now the hydrogen gas, we are going to collect it there. So that is how we are preparing. So let us look at the observation in our next slide. So we are saying zinc reacts with dilute hydrochloric acid to form a salt. The salt, we said, it's zinc chloride and hydrogen gas. This is the reaction here. Zinc metal, or the zinc granules, will react with hydrochloric acid, and The products formed will be zinc chloride and hydrogen gas. So this is the salt, this is the gas. We are saying zinc is the most preferred because it reacts moderately with dilute acids. So zinc is not explosive when reacted with dilute acids, and it does not react very slow. So it reacts moderately with dilute acids. So we most prefer to use zinc metal of all other metals. So zinc metal react moderately with dilute acids. So we said in the conical flask containing zinc granules, there will be bubbles, indicating that there is formation of a colorless gas, and the gas is hydrogen. So in our conical flask, we can add a small piece of copper 2 sulfate. That copper 2 sulfate will help in speeding up the rate of reaction. The copper 2 sulfate acts as a catalyst in our experiment. So copper 2 sulfate will speed up the rate of reaction. It will speed up the rate of reaction between hydrochloric acid and zinc granules. So the hydrogen gas will be produced more faster. So copper 2 sulfate is used as a catalyst in our reaction. Hydrogen gas, we said it is collected by a method known as overwater method, since it is slightly soluble in water. It does not dissolve in water. If the hydrogen is required dry, it can be passed through concentrated sulfuric acid to dry it. Then we cannot now use the overwater method. When we need it dry, we are going to use the method known as upward delivery method or downward displacement of air. So we cannot dry it and then pass it through water again. So we are not, it could be a mistake if you pass it again but through the water by overwater method. So we use the upward delivery method to collect the dry hydrogen gas. Another drying agent apart from concentrated sulfuric acid is the anhydrous calcium chloride. So anhydrous calcium chloride can also be used to dry hydrogen gas. Nitric 5 acid is also is not used to prepare hydrogen gas. Reason: nitric 5 acid oxidizes the hydrogen being produced to water. So there's no way we can be producing hydrogen and then we oxidize it to water. So we want to collect our hydrogen. So we cannot use nitric 5 acid because it oxidizes hydrogen to water. So that is a question that can be tested and be asked why we do not use nitric 5 acid. The reason we will say it oxidizes hydrogen being produced to water. When we come to the part of metals, sodium and potassium metals, they are not reacted with dilute acids. Sodium, potassium, calcium, lithium, these are most reactive metals and they cannot be reacted with dilute acids. This is because the reaction between these metals and dilute acids is very, very explosive. So for safety reasons, we do not use those metals. Again, the least reactive metals, for example, mercury, silver, and copper, they are also not used because the reaction cannot produce hydrogen gas. They do not produce hydrogen gas. They are very least reactive. Magnesium is another metal that can be used to prepare hydrogen gas. But why don't we use magnesium? Because magnesium is very expensive. It will make this process very, very expensive. So to minimize on cost, we use zinc in place of magnesium. Also in pure iron, iron is not used. It contains a mixture of gases. So that is the end of part 1. Remember, in part 2, we are going to continue and see how now our hydrogen that we have produced can be tested. So how can we test the gas that we have produced in the lab is hydrogen gas? So that is what we are going to look at in part 2 of our lesson 2, and again also look at the chemical properties of hydrogen gas. Thank you.